Okay, the multiplicative law of probability. That's what it's called. Multiplicative law of probability. There. Okay. So if you're familiar with statistics, then you may know about the addition and multiplication laws of probability. We're only going to do it with the multiplicative laws of probability in terms of connecting them to the Punnett squares that you're doing, right? Which you're going to need to be able to do. So the multiplicative law of probability basically says this. If two events are independent, or i.e. can happen at the same time, right? Can be true at the same time. At the same time. Right? Their total chance, right? The total chances of happening together are the product of their chances of happening alone. And that's going to sound like Greek until I do an example. So if two events are independent, it'd be true at the same time, right? Their total chances of happening together are the product, meaning you multiply the chances of each occurring by itself. So for example, if we're talking genetically, being born a girl with blonde hair. Those are two separate events. Being born a girl with blonde hair can happen together, right? They are independent. They can happen simultaneously. So you got to figure out, well, what are the chances, given whatever the parents are, of the person having brown hair. Sorry, blonde hair. I said blonde hair, didn't I? Okay. So first, figure out chances of having blonde hair given the parents. So let's say. Just write the question first. What are the chances of this couple having a daughter with blonde hair? There. Okay, and let's say that their genotypes are, let's do this. So let's go big B gives you brown hair, and little b gives you blonde hair. Blonde hair does tend to be recessive. Okay, so let's say that the parents are heterozygotes. So this is a classic monohybrid cross, right? You could do that in your sleep. You don't even need to draw the square. You should know what the result will be, right? First of all, let's handle the hair color. The chances of this individual, regardless of what the gender is, having blonde hair is what? Give it to me in terms of fraction. 1/4. Yes, yes. Following? So yes, 25% is correct, but when you're multiplying, when you're doing the law of probability of multiplication, it's usually easier to use fractions. So we're going to use fractions. So the chances of blonde hair, regardless of gender, would be 1/4 chance of blonde hair, right? And all you do is you just remember what a monohybrid cross looks like, right? So if you were to actually do the Punnett square, you should be able to see that in your mind. I don't think I need to do that for you. Do I? I hope not. So 1/4 chance of blonde hair, right? Okay, now what about separately, what are the chances of this couple right? I'll just do a complete picture here so you're not confused. This couple who, in terms of their sex chromosomes, here's mom, right? And here's dad. And we don't have any sex linkage here. We're just here treating this as gender, right? We're just putting the X's across and down. What are the chances of any couple having a girl? 1/2, that's it. That's it. So this is not sex linked, right, exactly. This is just a problem of what gender could any couple, male and female, have? And it's always going to be 1/2 chance of a girl, right? Got the girl, not Bert. Oh, gosh. It's already been that long a day. Okay, so 1/2 chance of a Gert. Right. Okay, so now, total chances. Total chance of blonde daughter. You already figured it out in your heads. Tell me what it is. Yes, 1/8. Exactly. Beautiful job. That's it. And that's the kind of problem that you'll see in the AP exam. You might see this. In my exam that's coming up, you'll see this. Right? Okay. So that's how you handle the multiplicative property. You have to first get the separate chances of these two events happening. Often that will involve Punnett squares, and then multiply them together to get a total chance of them happening simultaneously. And that's that. Okay, and I think you guys have that. It's not real difficult, but you need to have it explained at least once to really get that.